Assalamualaikum and hello everyone. Welcome to a video for 5.2 Alkene, where in this video we will learn to outline the mechanism in dehydration of alcohol. Okay, previously we have learned all of the reaction in alkene. I also have discussed it in the video for the mind map or the summary of alkene. Okay, so right now what we're going to learn is the mechanism in 5.2. Okay, in 5.2 alkene, overall mechanism that we're going to learn is actually 3. Okay, in chapter 5 itself, hydrocarbon, we will learn 4 mechanisms. Where the first mechanism that we have learned is actually in 5.1, where the halogenation of alkene or the free radical substitution. Okay, so in 5.2, we're going to learn the rest of the mechanism, which is each of the mechanism ni is quite different to one another lah. Okay, however, for the chapter 5 itself ni, especially 5.2, I'm not going to be focusing much on the mechanism because in JPU, for chapter 5, total marks is 6 or 7. So I believe it won't be much of the mechanism itself lah. So the marks for mechanism pun dah 3-4 markah for each mechanism. So that's why I would rather be focusing on the reaction itself. However, for the mechanism in 5.2 alkene, most of the mechanism we're going to do it together. Okay, so without further ado, let's look for the mechanism of dehydration of alcohol, which is on your notes on page 18. Okay, so for the dehydration of alcohol, that is the name of the reaction. Okay, so dehydration. So it means that we're going to remove dehydration, remove water lah. So where there is removal of water molecule, removal of our atom or molecule, so it means that the reaction is actually elimination reaction. Okay, so for the elimination reaction, it follows Sitz's rule, where it mentioned that the alkene with a greater number of alkyl attached to carbon-carbon double bond is the major and stable product. Okay, so for the dehydration of alcohol, what we're going to remove is actually remove water. But in our alcohol, we do not have water attached to the carbon itself, kan? So it's actually what we will be removing is actually remove the OH from the carbon that containing OH itself. And then next, we're going to remove our hydrogen. Okay, removal of the hydrogen too, it must be from the carbon next to the carbon containing OH, where if we have the carbon to different classes, we have to consider lah yang bab tertiary, secondary, primary, we have to consider it for our major and minor product. Okay. Okay, so let's look for the first example is the dehydration of ethanol. Okay, ethanol. Ethanol ni, ethane ni is means that we have two carbon. Nol ni, it means that we have OH attached to the carbon itself. So we have 2 carbon and one of it must contain OH. For the dehydration of alcohol, what is the reagent? The reagent is concentrated H2SO4 and we need heat as well for this reaction. Okay, so again, what would happen for this reaction itself? First, what we're going to remove is actually, we remove the OH. So, remove one OH ni. Okay, next is actually remove hydrogen too from the carbon next to it. So, we're not going to remove the hydrogen from the same carbon, kan? We're going to remove the hydrogen too from the carbon next there. Then one carbon, the carbon next to it, only one here. We have here, so what we're going to remove? We're going to remove one of the hydrogen. So in this case, I'm going to remove the hydrogen from here lah. Okay, remember the OH pun must be removed as well. Okay, so actually the byproduct for this reaction is H2O because we remove water. Okay, but what about the product itself? Okay, so again, what we're going to do is actually we're going to remove the H and OH. Okay, so for the dehydration of alcohol ni, what happens is that we're going to form alkene. Okay, so when you look at the carbon here, each of the carbon ni only has 1, 2, 3 bond. Okay, sebenarnya kalau kita letak dekat sini, when we form our alkene, carbon-carbon double bond, when we count back, the carbon ada 1, 2, 3, 4 bond. Okay, so that is actually the reaction equation. This is only the reaction equation. Next, what we're going to look at is actually the mechanism. Okay, for the dehydration of alcohol, there are 3 steps. The same as yang free radical substitution tu, halogenation of alkene yang IPT tu kan, initiation, propagation, termination. But for the dehydration of alcohol, it's enough for you to write down step 1, step 2, step 3. This one is actually the one that I highlighted ni is actually the explanation sahaja. Okay. So let's look for the first one, protonation of alcohol. Okay, so before we're going to look further into the step 1 ni, okay, here I'm just going to be focusing this part. Okay, previously we have learned for the free radical substitution involving radical, we will use half arrow kan. So mechanism tu banyak kita guna curve arrow, half headed. Okay, for the next mechanism, the rest of the mechanism, we're going to talk about the movement of the electron tu is between concerning two electron itself. So we're going to use full arrow. So macam mana kita nak buat? Kita akan buat curve arrow, lepas kita akan buat full headed arrow. Okay, again, kalau yang radical tu curve arrow, lepas tu half headed kan? Distraction curve arrow, but it is full headed arrow. Okay, and then the reaction ni, the arrow tu must be from rich electron species to poor electron species. Rich electron ni, hint dia, it must contain lone pair or it contain negatively charged. Okay, so how about the reaction itself? Okay, so first step is actually the protonation of alcohol. So protonation ni, it means that we're going to add H lah. Okay, so what happen is that from our alcohol ni, we're going to add H. Okay, H2 we're going to add to our OH itself lah. Later on it will become OH2+. So here. Okay, so how does the reaction work? Okay, so kita ambil dulu our alcohol, in this case ethanol. It will react with our reagent H2SO4. But for the H2SO4, actually for the mechanism, easier for you to write down it in terms of HOSO. Okay, why HOSO? Okay, let's look it here. Okay, HOSO. Actually, when we count it back, HOSO ni still lagi H2, SD1, oxygen the 4. So again, masih lagi H2SO4. But it's easier for you to write down in terms of HOSO. Just to show it to you, it will be easier for us to see that the alcohol ni take hydrogen. Only one hydrogen from the H2SO4. Okay, so that is the reagent. Okay, how is the mechanism or the movement of electron tu? It must be from rich to poor. Maknanya kaya ni mesti suka kacau yang miskin. Samalah macam kita fikir kaya ni mesti suka menderma ke miskin kan. Ada juga miskin yang meminta dekat kaya. Tapi macam tu lah. Kita assume macam tu lah. Rich ni. Rich electron ni dia yang baik. Di electron ni semua yang baik-baik je. Dia yang mencari. Okay, siapa yang tak cukup, we give the electron. Macam tu lah Okay. So, which of these species ni yang rich electron, poor electron? Okay, actually, kat sini, our alcohol here, our oxygen, still remember, oxygen ni, it contains 2 single bond, and it contains, ataupun 2 covalent bond, and 2 lone pair. In this case, our alcohol ni, dia attached to OH, kan? Contain 2 hydrogen, and it is attached to carbon as well lah. Sebenarnya macam ni. So, it's up to you whether you want to show the the lone pair or not. It's just that I show it here to show that the movement of the electron must be from the rich to pada yang poor. Okay, dalam kes ni, which one is our poor species? Is our hydrogen lah. Okay, in this case again, but because of the protonation of alcohol, remember OH ni, it wants to take 1 hydrogen. So, maknanya, from the oxygen ni, the electron, the movement tu, the arrow must be towards hydrogen. So, the arrow, again, curve arrow. Okay, and then full headed arrow because this is concerning to electron kan. Okay, so this will be the arrow. Okay, so what will happen to the product? Okay, what will be the product? It will be like this. Okay, this one, it won't be ethanol macam biasa. Right now, it has taken the hydrogen, so the OH2. Okay, but then right now consider the oxygen ni dah donate the electron towards hydrogen kan. So what happens is that dia dah donate, so jadi positif. Ingatlah, kalau yang donate, must be a positively signed donate electron. Okay, but then what happened to yang osoh ni? Okay, we have to show because the oxygen here, the electron has taken the hydrogen. We have to show that this bond break. Okay, when this bond break, this is concerning 2 different atom kan? And then this is actually our heterolytic cleavage. So for the case of heterolytic cleavage, the electron ni will be shared towards more electronegative atom. Okay, for the order of electronegative atom, remember, we suka guna senaf-senaf kan? Carbon, nitrogen, oxygen, fluorine. This is considered the most electronegative atom. So in this case, oxygen is more electronegative. So the electron here, remember one bond we have two electron. So up to you whether you want to draw one electron one bond ataupun nak show tu electron ni pun is fine. But you have to show the electron ni akan will be moving towards oxygen. Okay. So how about the arrow? From the electron towards the oxygen, curve arrow. Okay, and then make sure the full-headed arrow. Okay, so what happened here? Dia akan jadi, it won't be hosoh anymore. It will be osoh. Osoh here. But then again, our oxygen ni gain electron ataupun accept electron. So once it accept electron, it will become a negatively charged. Okay? The negatively charged ni must be towards oxygen ni lah. Oxygen is the one that containing the negatively charged. Remember, donate. When it donate, the electron become positive. If it accept electron, it will become negatively charged. Okay, so that is actually the first step, the protonation of alcohol. So again, here we're just going to take it as osoh. Osoh ni sebenarnya sama juga kan, HSO4 minus. But again, HSO4, betul lah, HSO4 minus. Okay, just let it be like this because actually this one nanti we're going to take this excess species in our step 3. Okay, so that is actually for step 1. Okay, step 2 is the formation of carbocation and the loss of H2O. Okay, what is carbocation? Carbocation yang carbon plus kita ni lah. Carbon that contain positively charged. Okay, so we're going to take the product from our first step. Okay, we're going to take for the second step. Okay, so what happened here is actually loss of H2O. It means that we're going to remove the H2O. Okay, mana H2O tu? Okay, H2O is actually the one that containing to this species lah. Okay, we're going to lose the H2O ni because we're going to form our byproduct, our H2O itself. Okay, so what happened here? Our H2O ni is a good living group. Maknanya dia suka, it likes to exist as H2O. Right now, it does not exist as H2O. It exists as H2O+. So does not want that. It wants to be H2O. So what will happen? This bond will break. Okay, dia nak remove itself from this compound. Okay, but then when we're talking about bond breaking sini, it is about our heterolytic cleavage. Okay, when there's the bond breaking, the electron will be shared towards more electronegative. In this case, between carbon dengan oxygen, oxygen is more electronegative. So when the bond breaking ni, this electron here, what is going to form? Okay, again, Miss buat 2 dot. Okay, what happen is that the electron will be moving towards oxygen. Okay, towards oxygen ni. So we have to show curve arrow, but the arrow tu must be towards oxygen lah. Okay, so what will happen to the product itself? So we're going to show the product. Okay, so what happened here? The OH has left the group lah. Has left the chat table. So kita remove lah ni. Okay, again what happened here is actually the carbon ni dah donate the electron towards oxygen kan. So what happened? Kalau dia donate je, it will become a positively charged. Okay, but then what happened to our H2O ni? Okay, H2O ni, kita memang tahulah water memang neutral molecule lah. So plus H2O, which is our byproduct. Okay, why dia jadi it become a neutral molecule? Okay, because it contains positively charged, right? Okay, and then they accept electron. So when it accept electron, dia negative. So positive, negative, cancel out. So form lah our water. Okay, so that is actually for step 2. The formation of carbocation. This is our carbocation. And then loss of water. We dah remove the water from the compound itself. Okay. Okay, last step is actually deprotonation of alcohol. So deprotonation ni, it means that we're gonna remove the hydrogen. Okay, remove the hydrogen tu from which species? Yang product from second step tu, this one. So we're gonna take this one. Okay, lepas tu what we're gonna take next is actually remove the hydrogen. But how do we remove the hydrogen itself? Okay, so sebenarnya sebab tu lah pentingnya kita tengok balik step 1. Okay, we're gonna take back our osoh ni. Yang osoh ni, we're gonna assume it as a catalyst lah. Sebab at the end of the reaction is still the same. So it won't be osoh. Dia nak jadi balik hosoh. Okay, so we take this one. So when we take this reaction plus dengan osoh ni, okay, what happen is that the oxygen here, the osoh wants to take the hydrogen to become hosoh. But which hydrogen they can choose? This one, this one, this one, this one, this one. Okay. So the removal of the hydrogen, where the osoh take the hydrogen to. Remember, we're gonna remove the hydrogen from carbon next to the carbocation. So this is our carbocation kan? Okay, so we're not gonna take from the hydrogen attached to it. Kita akan remove hydrogen from carbon next to the carbocation. So next to it is actually this one. So which one you're gonna remove? We're gonna take this hydrogen lah. Okay, again, why? Sebab kat sini pun Miss dah ambil yang hydrogen dekat sini kan? Okay, so what I'm gonna take. So which hydrogen will the osoh take? Remember, the movement tu must be from rich to poor. So rich case ni negatively charged from our oxygen. Take lah our hydrogen. Curve arrow. Lepas tu make sure dia adalah full headed arrow. So next, what happen is that for our product ni, osoh ni akan form balik kita punya hosoh. Up to you nak write down hosoh ke, nak write down H2SO4 pun accepted. Okay, so what happen next is actually is for hosoh ni. What happened to our carbocation species ni? Okay, so what happen next is actually once the hydrogen is taken, so what happen here, from our bond here, that akan form our alkene. Okay, so how do we get there? So maknanya from here it will become our product ni kan, our alkene here. So it means that the electron sebenarnya ni shortcut lah. What happen here is actually when oxygen take the hydrogen, first step is actually the electron here will be shared to the carbon. Lepas tu dekat sini, once the electron dekat carbon ni, dia akan share di sini pula. With the carbon next to it. Sebab dia dah banyak elektron. Tengok sebelah dia ni pole. Positif ni kan pole kan. For the mechanism of electron ni, dia baik sikit. Kalau pole je, dia suka dia rumah elektron. So dia punya shortcut dia, you just no need for you to write down banyak elektron, banyak step yang macam arrow towards here, then arrow towards here. Dia jadi a compilation ataupun shortcut. Tunjuk sahaja one electron here. So how do you know the electron ataupun the arrow here? Tengok based upon our product lah. Okay. So what happened here for our product? It will become like this. So from here. Okay, originally is like this kan. So maknanya dekat sini kita ada positif. Okay, so actually the electron here, because this carbon share the electron with this carbon, so dekat sini dah tak adalah positively charged. And then here we will have our alkene, our product. Okay, so that is actually the mechanism. Okay, again, mechanism for elimination ni is completely different to our free radical substitution. Okay, where we have 3 steps. Again, the one that I would like to emphasize, the arrow itself must be full-headed arrow. So you can see semua ni full-headed. Memang full-headed lah. Maknanya curve, lepas tu arrow yang 1, 2. Here curve, 1, 2. Make sure where we have, when the electron is donated, it means that the atom itself contain positively charged. If it accept electron, it will become a negatively charged. Okay? So again, if you are unsure, you can look at the time step and check lah which step you are not comfortable with. Okay, next step is actually what I'm going to do is for the 2-propanol. Again, yang ini Miss akan buat fast forward. And ada some background music, but then you can check it yourself lah after you have done, after you have tried yourself. Okay?